All right, so if you've seen a rocket talk on YouTube or whatever, much of this, well, you've seen like 99% of the slides. But anytime I give this talk, it's always a little different. So hopefully there's still enough new information that you guys find this useful. So I want to give this talk, but I also just kind of want to talk to you guys about Rust and what do you want to do with Rust. There seems to be a lot of people that are learning Rust or want to learn Rust and want to do stuff with Rust. Some of you already know what you want to do with Rust, some of you don't. So hopefully we can talk a bit about what you want to do with Rust. And I also want to share things that I don't have slides for, things that I'm working on that you guys might find interesting, and hopefully you can glean some information off of that into your own projects, into your own work. So I guess the first part of the meetup, I kind of wanted to be just the talk, just kind of let you know what Rocket is, what Rocket does, a little bit about how Rocket works, and why, if you're writing web stuff in Rust or in anything, you should use Rocket. Why Rocket is a good choice, I think, for writing web applications. Okay, so let's get started here. So that's me. That's my name. It's Sergio. That's my email address. It's sb@sergio.bz. If you guys have any questions, just feel free to send me an email. I'm more than happy to reply. Sometimes it takes a while to reply, but I will reply to you eventually. So feel free to send me any messages that you want. So this is Rocket's logo again. Okay. So for those of you who may not be familiar with Rocket, Rocket is a web framework for Rust that has a few goals. Its first goal is that it makes it very, very, very simple. Think, Python style simple, not what you might imagine in a language like Rust or Haskell. To write very fast, very, very fast, like C speed. We're writing in Rust, we deserve the speed of something like C. Without sacrificing flexibility, so you should be able to do what you want, not what the web framework wants you to do, or type safety. We have a very strongly typed language. We have Rust. We should use the power of Rust's type system to get, goodness, security, and correctness out of our web applications. So just to be as clear as possible, what I mean by web framework is, your Django's, your Flasks, your Rails. If you're familiar with any of these three, these server-side web frameworks, then that's what Rocket is. It's in this class of libraries. It's different than all of these. It's not like any of them, really. It looks mostly like Flask, but it also lets you do things that you can do in Rails and Django for free. So it's sort of this weird mix of things that I think is totally new and particularly exciting. And so Rust, we all know Rust. Rust is our favorite programming language, hopefully. So Rust is this wonderful language that's memory safe, without a garbage collector, no data races, very minimal runtime, and it has very powerful macro systems. All right, so as we know, Rust has two macro systems. We have sort of macros by example. That's when you do like macro rules. You guys have done that. That's the one macro system. And then there's a whole separate macro system called procedural macros. So if you guys have used like SERDI with derive, like derive serialize or derive to serialize, that's the procedural macro system. It's a system that allows the compiler to call your code at compile time to generate new code. All right, so that's what SERDI does, for instance. And it's this latter macro system that Rocket really makes a lot of use of. Rocket reads your code at compile time and generates new code. And this is where all of the simplicity, safety, and fun in Rocket comes from. It's because we have these macro systems, because we have a language like Rust, that we can even do this at all. Okay, so that's the good stuff. So Rocket's been around for a bit. I think it sort of gets close to these goals of being simple, fast, flexible, and type safe. This is sort of the timeline of where Rocket has come to fruition. So Rocket was released on December 23rd last year, so about 10 months or something. And then a couple months later, we had version 0.2. There was a bunch of very, very useful stuff. It was sort of hard to write some classes of web applications before 0.2. 0.2 made it much better. 0.3 kept increasing that. There's a longer time span because the features get sort of bigger and bigger. And so now we're over here, 0.4 is on the way. And people on GitHub seem to like it quite a bit. It's got almost 3,000 stars. We're a little higher than that number now. We're like 30 stars shy. So if everyone here presses the star button, Rocket will have 3,000 stars, and then we'll be in the 3K category, and we'll be very happy. All right. So there's one thing I don't show on this graph yet, on this timeline yet, and that's when Rocket was first used in production. And I just think it's so funny how quickly this happened, because I didn't expect it. I didn't expect people to be using version 0.1 of something in a language that's pretty new, using unstable features that you can't use in a stable compiler anytime soon. But they did, and that line goes right there. So just like a week after Rocket was released, someone sent me a message and said, "Hey, I'm using Rocket in production. This is really, really great." And I was like, "Thank you so much for beta testing the software. I hope things work really well at your company." So I was super happy to sort of see this. And it was exciting that people found it so compelling that they decided to rewrite some of their company's infrastructure with Rocket and with Rust, to say the least. So that's really exciting. Like I said, people on GitHub really liked it. When Rocket was released, it was sort of at the top of the highest trending open source project for the day, which was really, really humbling. Again, it was awesome that people were sort of buying into Rust and buying into Rocket as much as they did. Okay. So this is the graph. There's a whole part of this graph that I'm not showing. So I worked on Rocket for something like 8 months before I released it. It was sort of a full-time thing. Like I said, I'm a PhD student, or like he said, I'm a PhD student at Stanford. So this is partly research. There's going to be some research papers about this, but it's also very much so a thing that I want people to use. This is not a research project in the sense that you shouldn't use it. This is a research project in the sense that hopefully very good ideas are in the product. Okay, so again, this is Rocket. Rocket is a web framework for Rust that ideally makes it very simple to write very performant web applications that don't sacrifice flexibility, let you do what you want, and are also very safe. Very safe. The type system gives you correctness and security guarantees. Okay, so this next slide, it's mostly a joke. So YOF. So this is a word I made up, YOF. It's the question that you should ask yourself when anyone says, "Oh, there's a new web framework." You should ask YOF, which is yet another web framework. Like, do we really need another? There are so many web frameworks in so many languages. Do we need another one? Well, maybe not. Maybe we don't need another one, and Rocket should not exist. But for one, we have a new language. We have Rust. And there's nothing, I didn't think there was anything compelling enough in Rust. So maybe we need a new web framework for Rust. But I think we need a new web framework, not just because we have a new language, but because every web framework, in my opinion, sort of fails at something. And hopefully we can make something that fails at as few little things as possible. And when I say fail, I mean things like security. So these things here, these are all security vulnerabilities. These are all problems, security issues that your web application can have. If you were to write a web application using something like rack in Ruby, or USWGI in Flask, or Hyper USWGI in Python, or Hyper in Rust, you will be, unless you take very good care of how you write this thing, you'll be vulnerable to all of these things, right? So these are all issues that you need to be aware of if you're going to write something sort of at the low level of the web stack. So, well, hopefully you don't write things at the low level of the web stack. You write things using a web framework. So if we write something in Rails, for instance, or Django, many of these things will be addressed for you, and you don't have to worry about them at all. In particular, these things in green here are sort of immediately fixed for you. You never have to worry about SQL injection if you use Rails, for the most part. You never have to worry about cross-site request forgery. These are all security issues that the web framework totally fixes for you. You don't have to worry about it at all. However, there's all this stuff that they don't fix for you, or that you really wish they fixed for you, but they didn't for reasons that are unbeknownst to you. Things like remote code execution. That's an attacker injecting code into your applications, or passing code to your application, and then your application executing it as if it was its code. All right, so this is just about as bad as you can possibly get. And this happened in Rails. This happened in Java web frameworks. This happened in very, very popular, well-used web frameworks, and it really shouldn't happen. Or things like input validation that are so generic. What input are you validating, and what is a validation? That question is so generic that nothing really tackles it. If you want to do input validation in Rails, you end up using things like filters and just like random if conditions that you chain around, and inevitably you get it wrong because there's no structure to this. Things like authentication and authorization. There are like libraries for Rails that will do this for you, and they work for the most part. But as soon as you want to do something different, Rails doesn't really help you. You have to reinvent everything. There's no system in Rails or Flask or Django or Sinatra or anything that helps with these things directly. And misconfiguration is something that really we should get right. Like Rails should just check your config and like abort if it doesn't make sense. But instead, Rails checks your config and it prints out a log message that says, "Hey, this may not make sense," and then it just lets you keep going. Right? Like there's no reason that they should do that, but they do. So we really want to fix these things. Can we do better? Can we create a web framework that fixes all of these things? And, well, hopefully the answer is yes, and hopefully the answer is Rocket. I think Rocket gets close to fixing all of these things. We use the same ideas that other people have in cases where there are good ideas. So we do the same things for directory traversal that everyone else does. We don't reinvent things because we want to. We just use existing solutions. But for these problems that don't have good solutions yet, well, Rocket introduces some ideas that you can use to sort of solve these issues. And the way Rocket does this is through this sort of philosophy. It has an idea about what your application should look like. It has an idea about how your application looks like to the type system and to you and to the world. And these are sort of the ideas there. So there are 3 core ideas, and these drive basically everything in Rocket. So if you've seen Rocket's GitHub, Rocket's issues, you'll see that I'm always trying to maintain these things. So the first sort of main idea here is that function declaration and parameter types should contain all of the necessary information to validate and process a request. You should be able to look at the type signature of a function that's handling a request, and the types in that signature should tell you everything that you need to know about how that request will be handled, and more so, what needs to be true about that request for Rocket to handle that request for you. Right, this is very different than just about every web framework. If you look at Flask, for instance, or pretty much all other web frameworks in Rust, you get this request object, and then you just look at things in the request object, and then you somehow write out a response. This is not the way it works in Rocket. You can't get the request object in your handler in Rocket. It's just not possible, which is weird, but hopefully things are nice and ergonomic. So this is very, very different, and this is really big, because you can look at a handler, read the types, and know what must be true and what will be true if the thing succeeds. So the second is that, very, very sort of in line with the first, is that all request handling information should be typed. If you're dealing with something, if you're dealing with input from the user, that input should be typed by the time that you deal with it. You shouldn't be dealing with strings that are actually numbers. You should be dealing with numbers that are actually numbers. You shouldn't be dealing with this weird JSON blob when you can just deal with a structure. And so Rocket's second sort of point here is that everything should be typed. You should never deal with things that don't have a concrete type in Rust. And finally, this is more on sort of what Rocket is going to force the users to do. And that's that Rocket should not force decisions on you. So as programmers, we want creativity. We want to do what we want, right? You don't want me to decide what you write. You want you to decide what you write. And Rocket very much so tries to respect that as much as possible. Sometimes you can't because of security, because of correctness, but anytime that we can, we allow you to do what you want. So Rocket really tries to be flexible. And where this really comes into play are things that other web frameworks build into themselves. So imagine like templating. Templating in Django is like a built-in thing. In Rocket, templating is not built-in. It's just a library that's totally outside of Rocket. But Rocket provides the tools to be able to write that. So yeah, so that's Rocket's third point, is that decisions should not be forced on this. All right, so the goal is to design a web framework that has these 3 points as its main central design ideas. And so Rocket is, hopefully that. And this is what Rocket looks like. This is, Rocket's Hello World. This is not Rocket's Hello World. This is what Rocket looks like. This is one sort of example capturing all of what Rocket does. Most of what Rocket does. So here we have this this handler. Actually, let me. I'm gonna move away from the camera. Sorry. All right. Yeah. All right. You can fix it. I'm gonna be here for a while. Yeah. All right. Yeah. So this is one thing you can write in Rocket. You can write whatever you want in Rocket. But let's look at sort of the important parts of this particular application. So the first thing you see is this thing at the top here. This is an attribute. So for those of you unfamiliar with Rust, this is an attribute, and it's basically declarative syntax for something. In Rocket, this is declarative syntax for the set of conditions that must be true for a request to match this handler, for a request to match this function here. So this in particular says that this function should be called when there are GET requests to some path that we're going to call it ID. The first segment is going to be ID. And we don't care what that is, we just want whatever text is in there to go into something named ID. And then there's the function itself. There's a function signature, really. And this is where all the types come in. This is where we talked about you don't have access to the request object. Everything is typed. So here we see that this function expects 2 types. There's a user type, and then there's this paste ID type. And you notice that the name of the paste ID type is the name that we had up here, this ID thing. And so Rocket will actually mash those two up and try to do the right thing to validate, or do the right thing to validate that type whenever that request comes in. And then we have this other type, this user type. And we'll see much later how exactly this works. But this user type is another condition that must be true for this thing to run. And in particular, we might imagine that this user type is some type that knows how to validate a user from the incoming request. Right? So maybe it looks at headers. It looks at a header for a cookie. The cookie gets decrypted and verified, and then you find a user ID in there and fetch it from the database, and then you say, yep, this is a user, and you pass that back in the user object. All of that Rocket will do for you, just as long as you put this user type in there. And you can put any types that you want. We'll see much more later. And then you also have this return type. And again, this is the same philosophy that types really need to, we want types to describe the functionality. So here we have this return type. So once our thing executes, it's going to return an option of a file. Right? So if you just kind of think about what that might mean, well, it means maybe we return a file if things go okay, or we didn't find the file. So what will Rocket do? Well, if you give us the file, we'll send the file to the user. If you don't give us the file, we'll send a 404 to the user. Right? So these types are directly describing the functionality of the application. So this is sort of the overview. This is how things look in Rocket. You have this matching conditions up top. Your type signature describes all of the inputs, and then your return type describes what Rocket's going to do with the response, and the function body itself actually processes the request information. Okay. By the way, if you guys have any questions while I'm moving through this, please feel free to interrupt me. Yeah, go ahead.
So, like the user type there,
yeah.
Is it like automatically serialization and deserialization?
Yes and no. We'll see more about this. So this is what's called a request card, and I have a whole section on request cards.
Okay.
Yeah, so if you give me like 20 minutes, yeah, hopefully your question will be answered in depth. All right. Any other questions thus far? All right, cool. Okay, so this is nice, but maybe this is nice. Maybe you don't like it. Maybe it's nice. But how does this sort of solve, these issues? Right? I didn't say anything about remote code execution. Maybe you can sort of imagine how it solves or how it gives you tools to solve input validation. We're not totally sure yet how this solves all these issues, and I will come back to these later on in the talk. But right now, what I want to do is convince you that these are real issues. Maybe you think, well, it's 2017, we don't have remote code execution problems anymore. Like, that doesn't happen in Rails. I'll tell you that it does. Maybe, authentication, authorization are like solved issues too. I'll tell you that they're not. So what I want to show you is a few examples of vulnerabilities, of exploits, of problems in real applications, in real software being used by tens, maybe hundreds of thousands of people that have had these issues. And so I want to convince you these are important things to solve, and then I want to show you how Rocket solves these. Okay, and I want to do that by looking at specific instances of problems. Now, these are things that I chose just because they were nice and easy to explain and made well for the talk. But there are so many of these. You can just look up CVEs and you'll find these. There are so many of these. So don't take the fact that I just am showing you 3 to think that there are just a few. There are many of these. So here are the 3 that I want to show you. So the first is a vulnerability in WordPress. What hopefully everyone knows about WordPress. The second is a vulnerability in Spree Commerce, which is a Rails application that is for shopping carts, and it's used by some big sort of American companies like Chipotle. I don't know if you guys have Chipotle here. You guys have Chipotle? No. All right. Think KFC. You know KFC? Yeah. Okay. Think KFC, but they sell Mexican food. All right. So they have a shopping cart on their website. I don't know what they sell, but they have a shopping cart on the website. And GitLab, which is just GitHub, open source GitHub alternative that you can also pay for. Also written in Rails. So WordPress. So WordPress is written in PHP, and in 2009 they had this vulnerability, 2853, and it was an impact level 10. 10 is as high as you can get. You can't do worse than 10. If you have a CVE at impact 10 for your application, you should be very worried, because that means that an attacker can do whatever they want with that application. And there are hundreds of thousands, if not millions, of WordPress instances in the world. So this kind of impact level 10 really impacts people at level 10. It's a serious problem. So here's the issue. Here is the CVE. Here is the CVE text. It says WordPress before version 2.8.3 allows remote attackers to gain privileges via a direct request to 8 different endpoints. So to break up what this means, it means that you could just send an HTTP request to 8 different URLs, and then you would be an administrator. Or you would be able to do what an administrator can do. And so WordPress failed to authenticate and or authorize the entity making the request. And the patch looked like this. So this is how you fix this. We can't see the colors very well, but these 3 lines here, those are adding an if condition to all these files, all these endpoints. And here I'm showing 4, but there are actually 8 of these. So they had to add these checks, these authorization checks. They said, if the current user cannot manage categories, then abort this because the user doesn't have the right privileges, right? And what I want you to notice here is, first of all, this is 8 different files that just had the same problem, and nothing alerted them to that. Hopefully Rocket fixes it. Hopefully your Rocket application doesn't compile unless you specify the right things. And we'll see how the type system actually helps us there. The second thing I wanted to see is, to fix this mistake, what you have to do is insert these if conditions. And this is PHP, so these if conditions are like very poorly typed. Like the parameter being passed in is a string. What if you change that permission name instead of calling it manage permissions, you call it, manage categories, you call it modify categories or something like that. Your code will run, but it'll be wrong, and your check will be wrong, and depending on how your current user can function works, maybe things will break. So these if conditions are the things we really want to get rid of, and we'll see that Rocket actually, one of Rocket's big things is to code generate these if conditions. You just say, I need a user, or I need an admin user, and that gets generated for you. Just as a point of trivia, so there was this fix, and then they had to fix it again, because in PHP, I don't totally get it, but in PHP you can't say like, these files, please don't serve them. I guess your web server could do that, but PHP can't do it. So they had to add these other if conditions. These are the ones they added in the previous slide, and they had a whole other patch set to add these if conditions to all the files to check a different condition. And this is sort of where Rust really helps us here, because Rust is this sort of, it has a module system. It has the idea of abstraction. You can have public and private members. Okay, so that's WordPress. And we'll see how Rocket gives you the tools to implement authorization and authentication such that you don't need if conditions, and the type system will help you not get it wrong. Okay, so that's WordPress. So now let's look at Spree Commerce. So like I said, Spree Commerce is this Rails application. It's e-commerce web application. Lets you run shopping carts for whatever you want. So there was no CD here for some reason, but this was on their blog. So they said, by passing the right parameters while updating a user, that user is able to assign any existing role to themselves. So this is pretty similar to the last one. All you have to do is issue a request with the right parameters as the body of the request, as the form body of the request, and you can specify which role you want to be. If you want to be an admin, you just pass in admin. If you want to be a regular user, you just pass in regular user. If you want to be a super admin, you just pass in super admin. And so this is pretty bad, because if you're running an e-commerce store and someone can be an admin, well, they can just create orders for themselves, right? They can just send orders to themselves. Or maybe you have pretty private data in this store, and your user's information is going to be leaked. So this is as bad as it can get as well. So what was the problem here? So the problem here is actually pretty interesting, because this problem not only affected Spree Commerce, but it affected every Rails application. And it continues to affect Rails applications. This is something that sort of is endemic to the way that Rails works. It's just kind of how you do things in Rails, and to a lesser extent in Ruby. So this is called the mass assignment vulnerability. And when sort of people realized that this was a problem, hundreds of thousands, if not millions of websites, web applications had to go fix themselves, because they were all vulnerable to the same thing. And the problem is as follows. So in Spree Commerce, but you can imagine any web application, there was this update user method. And this update user method gets inputs from a form, right? So someone fills out a form, to change their username or something, and that form gets deserialized into this params object. This params object is like a hash map, right? So if you had a field named, if your form was named user, you just do params user, and you get the fields in the form that user passed in. And then what you would do is you create a new user using all of those parameters. And this is Rails and Ruby, so everything is nice and dynamic. And so here you just pass in all those parameters as the fields to this user object. And those fields those things inside the hash map become fields inside the user. This can't happen in Rust. This is weird. For Rust, or if you use static languages, this is totally weird. This is the way it works in Ruby. And it's very convenient for some cases. And this is Rails. And so Rails has an ORM, right, is an object relational mapper. And so every object in Rails is tied to the database. So this user object is tied to the database. And if you save this user object, then you're going to save it to the database. Okay, so with that, what's the vulnerability here? Well, let's say you're in your database, you have this role field. And the role says, well, this is either an admin, or this is a regular user, or something like that. And then someone passes in a form with the role set to admin. Right? I could just send you any HTTP message. Nothing restricts me from sending you different messages here. And so what happens? Well, you get those params, and you create a user from that. And then Rails will save that user to the database. So if that user already existed, and that user in the database, that user class in the database has a role field, well, you've just allowed the user to change that role field in the database. So next time you do the check to say, oh, is this user an admin, the check will come back yes, and the user specifies what role they want to be. And the reason this happens, again, is because we're taking everything in this params user hash map and just assigning it to the field inside the user. That's where mass assignment comes in. And you can be whatever user you want. So this was really, really bad. And we can sort of see how this just won't happen in Rust. We don't have this kind of dynamism. And what's more, Rocket is very, very strict about what it accepts from users. And it sort of forces you, the developer, to be very, very, very disciplined in how you specify what you accept to the user, what you accept from the user. Okay, so the fix, by the way, was to remove this role field. So they just get the parameters from the user and they just delete this role field. This was their one-line change. There are better ways to fix this, and they didn't do that for whatever reason. This is what they did. Okay. So the last thing I want to talk about here is GitLab. So GitLab is this GitHub clone. It's open source GitHub clone. I had this CVE here. This was just last year, and it was Impact 8.8. So still pretty bad. I don't know why it's not Impact 10. It really should be Impact 10, but it's Impact 8.8. This is what they said in their blog. We discovered a critical security flaw. The impersonate feature was not properly secured. It was possible for any authenticated user, administrator or not, to log in as any other user, including administrators. So this is actually maybe a little bit worse than the other stuff, because with this vulnerability, what this is saying is that I can just ask, GitHub to be you. Now imagine that GitHub, if GitHub had this vulnerability, that means I can just take over any project, right? I can take over private repositories. I can take over whatever I want. This is what this vulnerability is. So this is pretty bad. And this one is particularly easy to show you the exploit. So I'm just going to show you the full exploit, how you would exploit GitLab if it wasn't patched. So what you would do is you would log in. So you would, I'm just going to use the word GitHub to make it easier here. You would log in to GitHub. And then you would check your cookies, right? You would just go to your web inspector or something and check the cookies. And then there you'll find that GitHub or GitLab has set an authenticity token, what they call an authenticity token. You would copy that value and save it away for later. And then you would send a post request to the GitLab instance at that URL, /admin/users/stop impersonation. And ID is going to be the username of wherever you want to be. So, if you want to be me, your username will be Sergio. And then, as the form data, you send in this method equals delete. That's a Rails thing. And the authenticity token that you copied from earlier on. And then you send this request, and then GitLab will respond back and say, yep, you're now whoever you wanted to be. And it'll give you a new session ID that identifies you as that person. And that's it. That's literally the entire exploit. It's one of the smallest proof of concepts that I've seen. This is all you have to do. So I want to show you the code, the buggy code. This is the actual code modified to fit the slide, but the actual code. Here is the Rails code. So we're seeing a lot of Ruby here. You don't have to sort of see most of it, but you do have to sort of see these lines here. And what I want you to focus on is this class at the bottom, this admin impersonation controller class. And so in Rails, again, just very quickly, in Rails, everything is a class. Rails is object-oriented. Everything's a class, and classes are tied to routes. So you get a route, and then this thing will run somehow. But the thing we want to focus on here is this destroy action. So this destroy action is the thing that's going to get run when we issue that post request. So that post request in the exploit we saw is issuing a request to this method here. So this method will run. And so what does this method do? Well, it computes this redirect. It computes a URL from some session value. And then it sets the user to this user variable. And this user variable is actually a method up here. So that's this def user. Let's see. It's this def user up here, and that just finds the username inside of the parameters. In particular, it finds the user in this impersonation ID thing. So it sets the user to that, and then it redirects that URL. Okay. So what we want is the user passing in a request can specify the user in the parameters, just as we saw before. So what we really want is for this destroy method not to run if that user has the wrong permissions, if that user has the wrong authority. So how do we do that? Well, here's what GitLab, that was called GitLab did. So what they did is they added this skip before action and before action. So these are filters in Rails. So they said, do not authenticate the administrator when this method is called. Okay, so that sounds a little dangerous, but maybe they're okay because they do something else. And they do something else. They say, do authorize the impersonator. Okay, so don't authenticate the administrator, but do authorize the impersonator. That seems reasonable. So what does it mean to authorize the impersonator? Well, that's up here. That's that method up there. So authorize impersonator. So what does that do? Well, that checks if there's a session, if in the session there's an impersonator ID, and by the way, we're not going to send that. As the attacker, we're not going to send that. If there is that value in the session, then find that user in the database and check that user is an administrator. Okay, so we're still checking if the user is an administrator. All right, so maybe you guys can see the bug here. Maybe if you're not too familiar with Ruby, you won't sort of see what's going on. I'll tell you that this program actually won't type check in Rust. This is like a very strange program, and it won't type check in Rust. So hopefully this would be caught, just because it's weird. But I'll tell you what the bug is. So the bug is in this authorize impersonator method. And the bug is that if you don't pass in, you the user, you control the session, if you don't pass in an impersonator ID in the session, then that if condition won't run, right? That if condition won't succeed. Which means you won't run the body of the if condition, which means you'll never check if the user is in fact an admin. So this entire authorize impersonator method just does nothing if the user doesn't pass in a session with the impersonator ID. So that's pretty bad. And so this meant that anyone can be anyone. Okay, so these are the three things that I wanted to show you guys. There's actually one more that I want to show you guys. We'll see if you guys are familiar with this. So this is Equifax. You guys know Equifax? Anyone familiar with that? So raise your hand if you're familiar with Equifax. All right, yeah, good, because this is like an American thing. So yeah, that'd be weird if you were familiar. All right. So Equifax, I'm sure there's like an analogous company, an analogous entity in China. Maybe someone can tell me. So Equifax is a credit bureau. So they have like hundreds of millions of Americans' information, like very private information. Like if you had the information that Equifax had, you can impersonate that person in real life. Right. So is there an analogous company in China? Government, I guess. The government has all information. All right, imagine Equifax is the government, and they had this vulnerability that let anyone basically see your information. And Equifax, so their web stuff was written with struts, which is this web framework for Java. Yeah, so imagine the Chinese government was like really easily hackable. That would be bad for many different reasons. But in particular, your information would be everywhere. So struts. So struts had this vulnerability here, another impact level 10, and I have an exclamation mark because it's really bad that Equifax is using struts and they had this vulnerability. So I'm going to keep this a little short, but here is the vulnerability, and you don't have to read that. But the gist of it is that you could send in a request with a content type header, and you put in some special information in that content type header, and then it would execute a command, a shell command in that header. So imagine you're running a web server on your machine, and I send you a request, and that means that you execute whatever code that I want. All right, that's like pretty bad. And this is how Equifax was hacked. And so I want to show you what this payload looks like. This content type header would look like. So it looks like this. So if you had this, if you sent this payload, this is Python, if you sent this payload with a command right there, if you put in whatever command you wanted in that string there, then the machine running the Struts web framework code would just execute that command. So, what do we put there? Well, maybe we like cat etc shadow and we see the passwords. Turns out that Equifax did a lot of things wrong. In particular, they just had like I don't know what the equivalent is for Chinese residents, but we have this thing called a social security number. You guys have that? Okay, passport numbers. Okay, imagine passport numbers were like really special and abused by the entire American, every American company, and they were like, if someone knew your passport number, it was like really bad. Maybe that's already the case. But we have social security numbers, and if someone knows their social security number, they can basically be us. So no one should know your social security number. And Equifax just kept around like a JSON file with every American's social security number, which is like really bad. So if you were able to run any command, maybe a good command to run is you cat the data, the data for all American social security numbers. And this was like not encrypted and not anything. It was just there. You just did it. It just worked. So that's Equifax and Struts. So this is remote code execution that allowed this to happen. So this totally happens. By the way, Rails also had a remote code execution vulnerability. In this particular case, it was really, 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 really bad. All right. So that's sort of on vulnerabilities. Let's get back to Rocket. We spent a lot of time talking about security. Okay. So finally, Rocket's Hello World. So this is Rocket's Hello World here. It's very similar to what you saw before. I'm going to go back to this side now. All right. It's very similar to what we saw before. Here is the route attribute. Again, it's a description of matching conditions. This one is the simplest we can write. It says, I match all GET requests to the route path. And then down here we have the route handler. And here the input type, there are no input types. And the output is a static string. And the route handler is the thing that's actually going to process the request, right? It's the code that Rocket will run when a request comes in to the get/path. And this is what basically your applications are going to be composed of, these routes. And if you were to run this application and you were to visit the route path, you would see, if you just visit the route path, you'd see hello world, right? And that's really all you write. You just write this, you go to the route path, and you see hello world. So really, really rather simple code here. Okay. In order for this to actually run, you need to tell Rocket that this route exists. It doesn't just know. You need to tell it that it exists. And the way you do that is through mounting. So routes need to be mounted to make Rocket aware of the routes. And so this sort of consists of a few different things here. The first is this ignite thing. So you got to start up the rocket before the rocket can blast off. So you call rocket ignite. And ignite constructs a rocket instance for mounting and launching. So we can mount and launch, we first need to ignite. And then you can call mount. And what mount does, it's the thing that actually makes Rocket aware of your routes. So here we have this routes bang, and we have hello. So that's the name of the function up there. And so that's how we actually tell Rocket this route exists. And the path at the left there is like namespacing. It's just like namespacing. And we can change that, for instance, to /hello. And so if we actually put /hello there, then every route inside of this list has to have /hello prepended to it. So we wouldn't just be able to go to the route path anymore. We'd have to go to /hello in order to see that hello route run there. Okay. And finally, you can call launch. And when you call launch, it actually starts up a server. So Rocket has its own HTTP server built in, and it'll just start up that server and start serving requests for you. Okay, and it also prints emojis. So Rocket is very fond of emojis. It prints 3 emojis. They look like this. So when your application launches, it prints a little wrench, a little satellite, and a little rocket. I don't know. I like emojis, so there you go. And it also tells you a lot of information about your application. Right? It tells you the address your application is going to listen on, the port, and a bunch of other things. And so this is your first chance to catch any configuration issues. It will also fail to launch if there are any problems, if it detects any problems with configuration. And it's very strict about these things. And then it will tell you all the routes that you mounted, the name of those routes, and then it'll tell you that it's ready to go, and here's the URL where you can visit the application. Okay, so this is the sort of the full, all the code you need to write, modulo, extra and create rocket and things like that. But this is the entire application. It's 8 lines, and this really is all the code you write, and this is exactly what you write. Okay, so this is a pretty boring web application. It doesn't do anything. It just returns a string. Well, if we wanted to get more exciting, instead of just the root path, we could change that to world, for instance, and now you can visit /world. A little more exciting. Maybe we can say /Sergio, and now it's, hello Sergio, and that's a little more exciting. But this is a pretty boring application, and it doesn't do very much. But Rocket lets you do a whole bunch of stuff. In particular, I want to talk about these 4 things. These are the 4 things that I want to talk about for the rest of the talk. I want to talk about dynamic paths. These are what we saw in the beginning, that /ID/ thing. That's a dynamic path. I want to talk about request guards, and that'll finally answer the question that was asked 20 minutes ago. And then data guards, which are another concept, and then type URIs, which are yet another concept. And I'm going to use this word guard a lot. Right? So a guard is just something that protects something. Right? So you guys have a lot of guards here. There's like a guard that let me into the building and stuff. So Rocket also has lots and lots of guards. It has like 4 different types of guards. And they are the thing that will protect your code from running in the wrong cases. So this is where all the power comes in. All the sort of unique stuff of Rocket comes in through these guards. But let's first talk about dynamic paths to get a taste of how things work in Rocket. Okay, so dynamic paths. So a dynamic path is anything in the URL up here that is in brackets, right? So here, for instance, we have 2. We have 2 dynamic segments, 2 dynamic path segments. The first one is called name. The second one is called age. And for every dynamic segment that you need to have a matching segment in the function parameters, in the function input parameters. So here we have one called name. Here we have one called age. If we were to mess that up, if you were to say, for instance, number instead of age, well, now we have a mismatch. Right now, we have name and name, but age and number. So that's bad. So what does Rocket do in this case? Well, this is all the compile time, right? Nothing is happening dynamically. So you'll actually get a compile time error. And the error looks like this. It'll say, oh, hey, there's an unused dynamic parameter named age, but you didn't use it. So there's nothing named age. And it'll say, oh, by the way, we expected an argument named age in the hello handler. It'll print out the handler so you can see what's going on. So this is, Rocket really tries to be nice with its error messages. Okay, so we'll go ahead and fix that, and you'll notice that everything is typed. Of course, we're in Rust. We can't have untyped parameters here. So the type of name is string, the type of age is a UH, an 8-bit unsigned integer. And really, it can be any type as long as that type implements a trait called fromParam. And in this case, Rocket itself implements the trait fromParam for string and UH. And what this does is it actually checks that parameter is the right type. So the handler can only be called if the fromParam conversion succeeds. Right? So if name is a string, it'll always be a string as long as it's valid UTF-8, then it'll just keep going. But age, not all strings are 8-bit integers. So only the 8-bit integers only the strings that are actually 8-bit integers will be parsed as an age and will be passed into this function. Otherwise, Rocket can't even call your function. So I was supposed to lead it to the slide, but I can't see them. All right. So that's nice. Let me go back real quick. So that's nice. This is kind of neat that we can parse parameters as types, and things just kind of work for us. This is what you write. Rocket does all of the work for you. You don't write anything else. This is all you write. But we can also use this power. Yeah.
The error message in previous slide.
Yeah. Sorry, that's the wrong direction. Yeah, this guy.
The unused variable
yep.
is An error, not a warning.
Yeah, it's an error. Yeah.
It's disallowed in this. In Rust, the unused variable, unused parameter is just an warning.
That's right. Yeah. So that's correct. But Rocket is way stricter than it's stricter than Rust even in this case.
Does Rocket open this feature attribute?
Sorry, does Rocket?
Rocket disabled this.
Oh no. This is only for parameters inside of the attribute. So if you had other functions in your application that weren't Rocket handlers and they had unused parameters, then you'll still get the warning from Rust and it won't be an error. This is only for dynamic parameters inside of the path string inside of the Rocket attribute. In this case, the get attribute. Make sense? Okay.
Can we validate the value of the parameters? For example, if we require 8 must be smaller than 100.
Yeah.
So 8 can be like 200.
Yeah.
So can we do something like that?
Yes, you can do anything you want. There is no type built into Rust that expresses every number under 100. So you'd have to, create a new type. You'd have to, my type that's under 100 or whatever, and then you'd have to implement from param yourself for that type. And the validation would, parse the integer and then check that it's, whatever restrictions you want in that integer. And once you write that implementation of the trait, you just use the type just as we did with string and U8. Right? You would put, instead of U8, you'd put my type. Make sense? Cool. Any other questions here? Yeah.
Does Rocket have a compiler plugin?
Yes. Yeah. All of this is working through a compiler plugin.
So the previous slide, the error is produced by the plugin.
Yes. Yeah. You can't get errors like that without.
Yeah.
You can't get errors like that unstable,
Yes.
and you can't get errors like that without compiler plugins.
That makes sense.
Yeah. It'd be nice if you could, but you can't yet. I'm actually working on that. But I want Rocket to run unstable, so it needs to do everything it does now unstable. So we need to do that unstable, and we will soon enough. Okay. So yeah. Oh yeah. So great. So this is nice. So we can parse things from the string, from the path, and it just kind of works for us, and it's real nice and real cool. But this has nothing, I haven't said anything about security. Well, one thing I talked about at the very beginning was directory traversal attacks. And a directory traversal attack is when you use a string passed in by the user as a path to a file in your machine, and you don't validate that the file being accessed by the user is a file that you want the user to access, right? So if the user passes in, /etc/shadow, and you just give them the bytes, you just read /etc/shadow, and you didn't want that to happen, that's a directory traversal attack. So Rocket uses this mechanism, these dynamic path, I call them path guards, just another kind of guard, a path guard, a segment guard, to fix that issue. And here's how it looks. So you want to write a static file server, but you only want the files inside of your static directory to be served to the user. Files outside of static should not be served to the user. This is the 4 lines of code that you write to write that static file server. This is 4 lines of static file server code. And here's what they do. Well, the first line just says, I handle all GET requests to any URL, basically. So this path ... So the ... is extra syntax to say, not only do I handle the first segment, but also every segment thereafter. So this is how we get actual full paths from Rocket. And the type of that path parameter is pathBuff, which, if you're familiar, pathBuff is the type for heap allocated paths in Rust. And the return type is a file. It's a name file. It just means that we know the extension. It's a Rocket type. It's just like file from the standard library. And the code just opens that file, prefixing static to that path, and then returns whether or not that path exists. Now, this code would be wrong if pathBuff was whatever the user passed in. If it was just whatever the user passed in, and it allowed everything the user passed in. Because, for instance, if pathbuff was ../../../ 100 times, and then /etc/shadow, then this static doesn't matter. It's just going to be blown away by the ../. And then you're going to open that file and return it to them. But this pathbuff implements this from param trait. And the from param implementation for pathbuff will verify that that path is actually safe to use as a suffix to anything. Right? So if your files function gets called, then you know you're not vulnerable to directory traversal attacks. That's a very interesting guarantee, I think, that you can't get in any other web framework. There's no other web framework where the author can say, if this function gets called, you will never be vulnerable to directory traversal attacks. Right? That's a very nice property, and Rocket gives you properties of that kind for basically anything that you want. You can look at a signature. I can look at this signature and say, oh, that path is a path buff. That means this thing will never be vulnerable to directory traversal attacks. Excellent. Done. Okay. So that's sort of dynamic paths. Any questions on this? Yeah.
If I have to go to the path, what error would I get?
Oh, what error will you get? Yeah, so, well, there's the error you get as the programmer and the error you get as the user. So I'll just tell you what happens. So what happens is that this doesn't validate, and so Rocket says, oh, something went wrong. This is not the right thing. And then you can either handle that or let Rocket handle it for you. When Rocket handles it for you, you'll get what do you get in this case? I actually don't know what the pathbuff implementation does, but basically the implementation for from param allows you to tell Rocket, oh, this failed, this validation failed, and here's the error that it failed with. So I don't remember what pathbuff does. My guess is it'll fail with a user input invalid, whatever that HTTP status coded is, and the user will get that. But you can also decide, oh, I want to handle the user input invalid case, and then send your own error. You can also change this type, pathbuff, to be an option of pathbuff, for instance. And when path validation fails, you'll get a none. And then you can handle it straight in the handler if you want. Or you can get a result of pathbuff and then the string, and you can get the bad string in the error case. So it's very flexible. Okay, any other questions here? Nope? Okay. So this is all about dynamic paths, and that's cool. What I want to show you next is I think the most interesting part of Rocket by far. It's where we get the most power. It's where you can do whatever you want. It's where the user type comes in, and that's request guards. So a request guard, it's a type. A request guard is any type that you specify inside of the inputs that isn't part of the attribute, right? So there is no type, there is no parameter names admin in brackets inside of the URL, inside of the get attribute, right? So that's how we know that this admin type is not a path guard or anything like that. It's a request guard. And you can have any number of these as you want. You can have, admin user, and then, whatever, API key or something. You can have 100 request guards if you want. And a request guard, what it does, the request guard validates the incoming request against any policy, an arbitrary policy. And it protects the handler from running if that policy is not met by the incoming request. Request guards they're types that are accompanied with a policy. So in this case, what might this admin user type's policy be? Well, the policy might be, I require the request to have a header, a cookie that decrypts with this key and validates with that key and identifies a user in the database where the user has the role admin. And when that succeeds, I'm going to return you a structure named admin user, and that admin user will have the user's information for the application to use. And only when it succeeds will this admin panel function get called. Again, these are guarantees that Rocket provides to you based on the implementation of the guards. Okay, so when it succeeds, this will be called. What happens when it doesn't succeed? Well, so guards actually have two things that they can do when they fail. So the first is that they just fail. They just say, nope, there is no admin user in this request. I have failed to validate the request. And in that case, when Rocket gets that notification, it will prevent any further processing of the request. So that request is seen as evil or whatever, and it'll just say, nope, this has failed. And the guard can specify what error to return to the user. So here we might return a user not authorized error. But instead of just failing, it can also forward. And so forwarding is another unique concept to Rocket. So forwarding says, okay, this has failed. I have not authorized an admin user, but maybe something else can validate this request. So I, the admin user type, cannot validate this request, but maybe something else can. Please keep trying. Forward this request to something else that can try to validate this request. So one thing that you might forward to is not an admin user, but a regular user. So we might have a second route. Both of them are to the /admin path, but one of them is ranked with a higher number, rank 2. And what this does is it tells Rocket, okay, you're always going to try the thing with the lowest rank. And then, if that thing forwards, try the next colliding route. So this colliding route means it matches the same conditions. So in this case, it matches get/admin with the next highest rank. And if you weren't to specify the rank, so in this case we have 2 routes to the same conditions, you actually get another error. This one happens at runtime because routes are actually dynamic. But you get this error that says, Rocket failed to launch because these 2 things collide. By the way, did you know about ranking? Ranking usually fixes this problem. And then you can go back and fix the issue by adding that rank there. Okay, so Rocket will try the route at the top first because that has a lower rank. By default, this route will have a rank of -2 or something like that. I forgot what it is. I think it's -2. And then it'll try the next highly ranked route, which is the route at the bottom there. So what's happening here? So what will this web application do when written in Rocket and run? Well, what's going to happen is if someone visits the /admin path, right? So they want to see the admin panel, Rocket will try to call the route at the top because it has the lowest rank. And this route requires an admin user type. And we just talked about what that might mean. So this requires an admin user to be authenticated and authorized by the request. If that request doesn't authorize an admin user, let's say that the admin user type forwards. So what Rocket will do is it will take that request and it will try the next route. In this case, the one right below it. That route requires just a user type, not an admin user, but a user type. And so what might that do? Well, it probably does everything the admin user type does, but it just doesn't check the role. Because the type doesn't specify the role, so it just doesn't check the role. And so if there is a user authorized by the request, then this one will succeed. But maybe that one, when there isn't a user, will also forward. And then we can have a third route. This route has no guards. It's just a route to the get/admin, rank 3, so that means it's the next one to be tried. This has no guards, which means nothing has to be true about this request for it to be processed by the admin panel redirect route. And if we combine all 3 of these things together, what we've actually done is implemented authorization and authentication, sort of using guards and forwarding. Right, so this totally encodes the policy, for instance, that if there is an admin user, then we'll return the template for the admin panel. If there is a regular user, then we can return a template that says, sorry, you're not authorized to see this page. If there is no user logged in, then we redirect them to the login page. Right, if you think about how you might do this in some other language, some other web framework like Rails, we'd have to have all these before filters and stuff. Or if you did this in PHP, you'd have to have all these if conditions. If you did this in Django, you'd have to do all kinds of things. But here we use the same mechanism, guards, and in this case forwarding, to implement authentication and authorization. All right, any questions on this? Yeah.
And so, I'm not sure if you're familiar with Erlang. In Erlang, we got something like this multi-clause function
Mhm.
definition. So there's one thing I don't quite understand here. Why do we need this rank here? Like like in airline, it's like the function has more than one class. So like you just run like match
Mhm.
to like only one class will match is like here like rank 1, rank 2, rank 3.
Yeah.
Why do we have something like this? Like to specify like this order. Like I'm kind of puzzled because I guess in some cases like maybe you like in some cases you want the order to be like this, and sometimes you want the order to be like that. Like in different scenario, like can you handle this?
Well, so you can only handle one scenario per route, right? So if like a route can't match two different requests, right? It matches one request. So you would never be in the case where you want to use these three routes in multiple scenarios, right? You'd have to have a different set of three routes, for instance, and they would have to specify, admin user, or whatever. They would have to specify their own thing.
So another question is like my system has a lot of like user roles, so like it's like you're paying yes to like all these organization code.
Yep.
And the thing is that I'm seeing this is really appealing to me. I want to rewrite it in Rocket now, but there's a concern is that like in some cases like if you want something like it must be a main 1 or main type 2 at the same time, or one of these kind of main, like what's the syntax to like?
Yeah. So, well, there's one thing you can do now, and there's one thing you're going to be able to do in the future. Okay. So right now you'd have to have a different type for all combinations that you want. And you'd have admin user 1 type, admin user 2 type, and those would be different roles. Admin user 1 and 2 type, and those would be different types. That's one thing you can do. That might not work if you have a combinatorial explosion of roles, right? That would be not a good solution. If your request identifies somehow which type you need, then you'd only need one type, but it may or may not. You could also use what's called a fairing. So Rocket has sort of middleware, very structured middleware. And in there you could record some information that allows you to make this decision in the future. But all of these second solutions that I said are not good. The right solution is to use different types so far. Now, in the future, Rust will have const generics, which allows you to have types that are parameterized by constants. And then you can use that constant in the implementation of that type. This sounds weird, and it is a little weird, but what this will allow you to do is have one admin user type that actually has a generic constant parameter. So say it's an integer, right? So you have admin user, and then as a generic parameter, the number 1, or something like that. And then in the implementation, you can actually use that parameter. So you just need one type, and it would be generic over the type of admin. You can even lift those generics up now into the type system and have one admin user type, as long as it's generic.
Is it like variance in like languages like on camera or
Variancy?
variance?
Yeah. Well, generics.
Generic.
Yes, which I think are what you're talking about. So think, C++, like templates in C++, but at the type level instead of code generation. Make sense?
Yeah.
Okay. Any other questions here? Okay. All right. So great. So this is these are the most powerful, most generic types of guards in Rocket, the request guards. And this is where all of the input validation stuff comes into play. This is where authentication and authorization comes into play. This is what would have prevented the couple of the issues that we saw. This would have prevented, for instance, the spree commerce issue. Maybe this would have definitely prevented the GitLab issue, for instance. This, if you encoded in this way, the type system helped you. Okay, so the next thing I want to talk about are these data guards. So data guards are probably the funnest part of Rocket to use because they take away so much effort that you'd need in other languages. So data guards are There are types. So in this case, we're going to see a task is going to be a data guard. And data guards are types that know how to effectively parse themselves from body data. So let's say you wanted to parse form data into this structure. Well, what code would you write in Rocket to do that? Well, we need a handler for that. In this case, we have a post handler, again to the root path. And then we have this data equals, and then another dynamic parameter. So data equals specifies this is going to be my data guard. You can have one data guard per route. So data guard is going to be named to-do. The parameter inside of the function that I'm going to assign to the data guard is going to be to-do. And that data guard also needs a type, right? So that data guard needs a type, and the type of that data guard in this case will be form of task. Right? So form is a generic type, and it has a parameter, and the parameter we're going to use, a type parameter, the parameter we're going to use is task. Now, in order for this to actually type check, that parameter needs to implement a trait called fromForm, but Rocket can just generate that implementation for you. So all you need to do is add derive from form to that structure. And if you add derive from form, Rocket will generate a parser that can parse a form into that structure. Okay. And so if we do this, then we can actually just get a form from the body data, and the parsing and validation will happen automatically. So, yeah. And how this is actually happening is that there's another trait called from data. So we had from param before, and then we had from request for request guards. Here's a from data. And the from data implementation will parse and validate the body data. So form implements from data, and it'll parse and validate the body data as a form. And any type that implements from data is allowed here. Right? And here we use form. And as I said before, the structure will be automatically deserialized from form data. There are other types that you can use. For instance, JSON. So if you change form to JSON, all of a sudden you're parsing JSON data into this task structure. And all you have to do was change the type of form to JSON. Then everything will happen for you. As long as you implement, here you have to implement another trait called deserialize from Serdi, and you can just derive that as well. But everything else will happen for you. All right, any questions on data guards? They're relatively simple. Nope.
What if there are extra field of task?
It will not parse. Well, there's a different type for form. There's a different type called lenient form that will allow extra fields. But form will not allow extra fields. Yeah. So yeah, if you want optional parameters. So in your task structure, you'd have an option of the type that you want. And then if Rocket doesn't find it, it will be a none. Yeah, any other questions here? Nope. Cool. Yeah, so this is, if you've used any other web framework in Rust, this kind of thing can be really not fun to do. Like you have to add middleware, and then it gets parsed, and then you have to find it later, and it's all dynamic and not very nice. But here it's all specified by the types. You say, I need the data, I need the body data, and I want that data to be typed as JSON of my structure. And everything else happens for you.
So does it support polymorphism about the type? For example, I have a different type of tasks. For example, we have different kinds of tasks, and like in Haskell, you can define an algebraic data type, which is a union of the tasks. So for each subtype, you get a different structure. Can we do this?
Yes. Yeah, just with an enum. You'd have an enum, and you derive deserialize from that. And as long as each internal type also implements deserialize, it'll do what you want. And you can ask whether you want a tag or not. And Serdi sort of handles this for us. But yeah. Okay. Any other questions here? Nope. Okay. So, second to last thing, or maybe it's the last thing. I don't actually remember. Let's say it's the second to last thing, just in case. Is typed URIs. So, if you have a web application, you're going to generate URIs to all of your routes, right? You're going to be calling your own routes to redirect the user, or to put it inside of templates and things like that. And it would be really nice if if we get those URIs wrong, that it doesn't compile, and that we don't have to actually write those URIs, so if they change later, they'll automatically change everywhere. And type URIs are what allow us to do this. So type URIs are a new feature in Rocket that, for example, say you have this route here, right? So you have this route, and it has two dynamic path segments. One's called product, and one's called ID. And you wanted to generate a URL to this thing. Well, one thing you could do is you could just, create a string with the specific arguments that you want. Right? You can just do /inventory/shirt/2417 or something. And sure, that would be fine. But what would happen if you changed this URL? So you changed your mind and you wanted to flip, say, product and ID. Well, now this path is invalid, right? And that's no good. We want Rocket or whatever web framework we have to catch those sort of type errors instead of URIs. And in fact, we can. So instead of using format, we use URI. And so URI is another sort of macro that Rocket gives you. And it takes the name of a route. So in this case, the name of the route is item. So that's item up there. And then it takes the parameters for that route. So in this case, product needs to be a type of product, and the ID needs to be an unsigned integer. And if we pass this in, Rocket will generate the URI for us. And if we were to switch the parameters, say product and ID, then this wouldn't type check because the parameters are in the wrong order. Now that's sort of not fun sometimes, so you can actually name the arguments as well. So you can name product, so you can say product equals product, ID equals 2417, and then ordering doesn't matter. But now names matter, so if we were to get the name wrong, for instance, if we were to, ordering doesn't matter, but if you were to get the name wrong, so if we said item equals product, then that's wrong. There's nothing named item inside of the route named item. And so for this, you get a compile time error, and it would say invalid parameters for the item route URI. And so here's your invocation, and it would say, by the way, the parameters are supposed to be product of type product and ID of type usize. And it'll tell you, I don't know the name item, and you're missing the parameter product. Right, so it sort of tells you everything you need to know to go fix this URI. So we go back and fix it, and so everything sort of works as we expected. We get the URI that we want, right? Inventory shirt 2417. All right. So finally, I want to talk. The very last thing I want to talk about. This is definitely the last thing. Is any questions, by the way? Sorry, before I continue. Any questions?
Order method?
Not when you use the names. So when you do product and if you do product equals.
URI generated.
Oh, it generates the correct. Yeah, it puts them in the correct order. Make sense?
So what if that's a completion, like you say inventory product ID, and then you got something like factory product ID. Which URL will be generated?
Well, they would have different names, right? So this one's called item, but the other one has to have a different name, and so it's whichever one you give the name for.
Oh, you mean like the name of the function will be different?
Mm-hmm. Yeah. You have to specify that, and Rust won't let you compile, a program with two functions of the same name. All right. So last thing I want to talk about, and this is I talked about this at the very beginning, that Rocket is supposed to let you write fast web applications, and so I want to give you just a little semblance of proof that Rocket is in fact fast. So let's talk about performance. Okay. So how fast is Rocket? So I benchmarked a few sort of popular web frameworks, Flask, Node, and Rails. Express, that's on top of Node, and Rocket. And here are the results for the throughput, just raw requests per second. So Rails and Flask are quite slow, and Node and Express actually do pretty quick, do pretty well. So Express does a pretty good job. Rocket is down here at the bottom, but it's faster than everything else. This is on a fairly slow machine, so doing 38,000 requests per second is not a lot. if we had a faster machine, we'd do hundreds of thousands of requests per second. This is on a somewhat slow machine with many cores. So Rocket is faster than pretty much every other high-level web framework. So this is throughput. The other number you want to look at is latency. How much time does it take for me to send a request and get back the response? Right? What's the latency in that? And here is where Rust really, really, really helps us out, because we don't have a garbage collector. We don't have a big runtime. Here's what those numbers look like. So here's Rails at the top. Very high. This is average latency. Very high average latency. Express does a little better, and Flask does even better. Flask is worse. And Rocket does sub-microsecond latency. So it's a very, very, very fast, very quick to give you back a response. Perhaps even more interesting than average latency is max latency. If I send a bunch of people come into my website and they're sending requests over the span of 10 seconds, what's the most that someone will have to wait for a response? So here's that graph. This is over 10 seconds. And so Rails is up there. Now Express gets really bad, presumably because the garbage collector now actually gets to kick in. I'm not sure what goes on, but Express gets really bad. And then Flask and Rails do really bad. Now Rocket is so small that this becomes the wrong graph. So I'm going to switch this to a log graph, a logarithmic graph. So that's this guy here. And so this is now logarithmic. And you'll see that Rocket is the only one that goes to the left, because it's the only one that has sub-microsecond max latency over the course of these 10 seconds. So it is significant. It is magnitudes better than most other web frameworks. This is mostly because of Rust. We don't have a garbage collector. We don't have this runtime. So it's just it just really beats the pants off of most other high-level web frameworks. Okay, and so to combine those two latency graphs in this logarithmic fashion, just to give you a sort of overview picture here, on average it does way, way better, and the max latency is also just way off the charts. Okay, so this is the complete picture. It's better all around. I'm sure you could find a web framework that people aren't really using that is low level that will do better than Rocket. But one that's only for now. It's because very little attention has been placed into making Rocket really fast. It'll get 2-3 times faster soon enough. And two, Rocket is a high-level web framework, but it imposes very few restrictions, very few performance restrictions on you because of the code generation. Okay, so that's all I have to say about Rocket. I hope you guys give it a shot. There are a bunch of, if you haven't used it already, if you don't know Rust, I think Rocket is a pretty good avenue to get into Rust. There are a lot of resources in place for you to learn Rocket. So if you go to rocket.rs, there's a guide, there's a tutorial on how to write a paste bin in Rocket. There are the Rust docs, there's news, there's a link to the GitHub repository. I'm more than happy to take you guys' PRs. This is me again, I'm Sergio, that's my email address. And I just want to thank you guys so much for the opportunity to speak to you. So thank you so much. If you guys have any questions, I'm more than happy to take them now.
So when can we use Rocket in stable compiler?
When can you use Rocket in stable compiler? Well, the answer is whenever the features that Rocket uses are stabilized. When those features are going to be stabilized is a harder question. It depends a lot on which feature you're talking about. So my goal is to get Rocket on stable within a year. Like, you should be able to ship your app on stable Rust, compile it within a year. There are several features that are being worked on very actively right now by the Rust core team, and those will get done sooner. There are things that I'm working on, particularly the procedural macro APIs, that will get done sooner. There are things that people aren't working on at all that will take longer, things like specialization. It's something that someone built and it works-ish, but it's like super complicated and no one is really spending the time right now to figure out specialization. So those will take longer. There are other things like constant expression, constant functions, and things like that people are actively working on right now, but it's just hard. It just takes time to build the infrastructure into the compiler. So, but I think in all, within a year is a good measure. I'd be very surprised if it was more than 8 months, but I'll say within a year to stay safe. Yeah. Yeah.
So, like, there's a web framework written like Circle Phoenix,
Yeah.
and like it got this fan by like providing this WebSocket like components called Phoenix channel.
Yeah.
So like, do you have any plan or vision for like what's going to happen in
For WebSockets?
like in Rocket?
Yeah. Well, I'll tell you that WebSockets will be supported as a first-class thing in Rocket by the time it reaches 1.0. The milestone right now is like 0.8 or something. We're about to ship 0.4, so still a ways to go. That being said, I don't have a great idea about the design. I've spent no time thinking about how to integrate WebSockets into Rocket's model. It's I don't know how it's going to look. At some point, I'm going to have to sit down and like design it and see what works and what doesn't. But whatever gets done, it has to be as safe, as easy to use, as flexible as everything else in Rocket, and has to fit in with that model. So I don't know what it's going to look like, but I can promise you that it's going to be nice and safe and have all the nice qualities of what Rocket does right now. It's going to be built in. It'll be fast. It'll do what you want. It'll give you nice compile time errors. I just don't know when. I don't know when, and I don't know what it's going to look like. But soon enough, and it's going to look great. So there you go. Yeah.
Can you elaborate on how Rocket helps to solve the vulnerability with structs?
Oh, yeah. So, here. Let me just pull up the struts vulnerability real quick. It is. Yeah, so this is the text for the CVE. So we see that what the issue was. I mean, it was actually a really strange thing. This wouldn't happen in Rust because Rust has no exception handling, no exceptions. But the problem, the real problem with struts was that in Java you have exceptions and you have exception catchers. You can try catch and catch exceptions. So the problem was that when the multi-part parser in struts failed to parse a multi-part form, it would raise an exception. And certain exceptions were caught by struts, and certain exceptions were caught by lower levels of struts, because exceptions get chained. And basically they didn't account for an exception kind, and it went to a really low level of exceptions that did basically interpreted code, interpreted the text as code. It wasn't supposed to get there because it wasn't the exception they expected, but it did. And so if you crafted it the right way, you get the right exception, and you get to the right exception handler, and it would execute the code. So, I think there's a lot of arguments to make about why this wouldn't happen. First, there's no kind of interpreter in Rust, right? Like Java has eval. Rust doesn't have eval. I can't just eval a Rust string. So just by principle alone, this would be super weird in Rust. Second, there's no exception handling, so this particular mechanism wouldn't be possible in Rust. Rocket, on the other hand, sort of where Rocket comes in, not just Rust, is Rocket is very strict about what it parses. It will never, there's no interpreter. We're never going to execute code in what you're parsing. We're only looking at data. You never write the parser yourself. It always gets generated for you. And it's extremely strict. It will never allow things that that aren't in your type signature, right? If we have a content type, we're never going to look at something that's not a content type. And so really the thing that prevents it here is twofold. One, there's no kind of interpreter in Rust. And two, Rocket's parsing is stricter than anything, really. It's just extremely strict. It accepts that and only that.
Okay.
Does that make sense?
Yeah. Well, from that, can you talk more about exception handling?
In Rocket?
Yeah.
Or in Rust?
In Rust.
In Rust, yeah. So there are no exceptions in Rust. So error handling in Rust is sort of through types. So let's see how quickly I can get to the next slide. No, I don't have it. All right, don't get it. So early on, we saw this option return type, right? And this option return can either be some or none, right? So if it's some, I have that thing. If it's none, I don't have that thing. So that's one kind of error, right? So instead of returning like a null pointer or something like that, you get a type that tells you this is here or not there. That's like the simplest kind of error handling. For a more generic kind of error handling, there's this result type. And result says, when things are okay, I get this value. When things are not okay, I get that value. And it's a concrete return value. There's no try and catch. You get the value of result. And then you have to inspect that type to say, oh, did it succeed or not? And there's really nice syntax. You can add a question mark at the end of it to automatically propagate that error up if you want to. So it sort of gives you some of that propagation that exception handling gives you, but it gives you a concrete value. And so this result type is what Rust uses for error handling. Does that make sense? Yeah, if you look up like results and the question mark operator, you'll see that's how Rust does exception handling.
Thank you.
Yeah, for sure. Yeah.
Is there any application server like WSGI in
No, there's nothing like. So the question was, is there something like RAC or USWGI or WSGI, I guess? No, there's nothing like that. Yeah, so Rocket doesn't plug into anything. It runs its own web server. So you can't switch the web server from Rocket. You have to use the web server it gives you. There's nothing like that in Rust. Personally, I hope nothing like that does come to Rust. I think it's actually pretty detrimental. And in particular, I don't think it works well for the language. Like, it kind of works for Ruby and Python because they're so dynamic. Like, whatever thing you want to plug into it, the types don't get in the way. But with Rust, I think it would probably get in the way. So, yeah. The closest thing there is to something like that is this crate called HTTP. So this is a crate that was released not too long ago. And they have sort of types like request and results, request and response, and like headers and things like that. And so the hope with that crate is that different web frameworks and different servers use those types, and so now you can all use the same types. But there's no middle ground like rack or something like that.
some standard application server like GU, or it can help you to do some graceful restart, so you can release your application seamlessly without downtime. Can Rocket handle the graceful restart? We are working on the production system. Graceful restart is very important.
Yeah. It doesn't do anything in particular. I'm more than happy to consider ideas. I'm more than happy to consider ideas. It doesn't do anything right now to handle graceful restarts. Yeah.
Rocket introduce features.
What's that?
Features.
Oh, futures, async. Oh, yeah. When will Rocket introduce futures? Well, the first question is, will Rocket introduce futures? The answer is, I don't know. Maybe.
I see there's an issue on GitHub.
Yeah,
Tracking this.
Yes. I don't know if... I'm not convinced futures are the right thing for us, personally. I don't want to say too much about it, because this is like a very polarizing subject. And then I'm on video, so then everything's recorded. And I'm held to my words for a long time. I don't know if futures are the right thing for us, frankly. They're certainly what people are betting on, but I really value usability, and I think the usability for futures right now is incredibly poor. And so, for me to sort of advocate people using Rocket and using something that I consider is not very usable is not something that I want to do. So, if futures become very usable, and sort of the async sort of world around Rust matures and converges on features, then there's deciding on using anything else is going to be a very bad idea, and then certainly we'll use futures at that point. I think it's really early to say if betting on futures is the right thing, but I will say that Rocket will be async by the time it reaches 1.0. That's guaranteed it will be async because of correctness concerns. What the mechanism we're going to use for async is, I don't know what it's going to be. Maybe it's going to be features, maybe not. Right now it's like probably, but we'll see. Yeah, so I don't know when. As soon as it's clear what the right thing to do for Rust is in terms of async, we'll do async. But we'll probably be async internally much sooner than that. Like maybe we won't expose features, but maybe we'll use features internally just because we want to be async.